Student, today we are going to discuss what is the ratio between the wavelength of alpha particle and wavelength of proton. Okay, this two ratio we are going to discuss. Okay, when the voltage is the same, that is the time we are going to discuss wavelength of alpha and wavelength of proton. Okay, first we learn relation between the momentum, Planck constant and wavelength. Okay, we know energy is equal to mass into mass mc square according to Einstein equation, and otherwise h frequency. Okay, so we'll get its mass is equal to h frequency divided by c square. Okay, as we know momentum is equal to mass into velocity. Okay, so now we have the mass of h frequency divided by c square. We got this is a mass, velocity we can take it as a c get cancel. Okay, so that means we'll get as a momentum is equal to h frequency divided by c. So momentum is equal to h frequency divided by c. As we know, wavelength velocity is equal to wavelength into frequency. So velocity by frequency is equal to wavelength. So frequency by velocity is equal to 1 by wavelength. That means frequency by velocity is equal to 1 by wavelength. Planck constant its momentum is equal to h divided by wavelength. Okay, now wavelength is equal to h divided by momentum. Okay, now kinetic energy is equal to we can take it as a ek. Kinetic energy is equal to half m v square. Okay, that I am going to relate with the momentum. Finally we will get the wavelength. Okay, then we are going to find alpha and proton. Okay, now the kinetic energy is equal to half mass. I am multiplying numerator and denominator, mass square velocity square divided by mass, because mv we can take it as a momentum. So we'll get energy is equal to half momentum square divided by m. So finally we'll get momentum is equal to root of so we can take it 2m this side, because of square I am taken as a root 2me. Okay, energy for the particle. Okay, energy is equal to it is a voltage is equal to work done by charge. So work done is equal to charge into voltage. Here we are going to talk about the energy as work done. Work done is equal to energy, so is equal to charge by voltage. So momentum is equal to root of 2mqv. Okay, as I said, yeah, alpha and proton having the same voltage. Okay, now we will be taken as a previous equation. Okay, finally I have the previously we got as a wavelength is equal to Planck constant divided by momentum. Okay, wavelength is equal to Planck constant divided by momentum. Now we had the momentum. Okay, momentum is the root of 2m charge voltage. Okay, now we are going to take it as a what is the wavelength of alpha particle. Then we are going to find what is the wavelength of electron. Then finally proton. Then finally we are going to take it as a ratio. First, alpha particle. You should know what is alpha particle. Alpha particle is the helium nucleus, 2 proton 2 neutron. Okay, that means total mass of alpha will be mass of 2 proton, mass of 2 neutron. This 2 is approximately equal. We can take it as a 4 times of mass of proton, the mass of alpha particle. Charge of alpha particle. Out of this helium nucleus only we are taken as the alpha particle. Okay, that means out of this only 2 is the charge. That means 2 times of charge of proton. Okay, so totally alpha particle charge will be 2 times of charge of proton. Mass of alpha particle will be 4 times of mass of proton. Okay, now what is the wavelength of alpha particle? Wavelength of alpha particle, it's a Planck constant divided by root of 2 times into mass of alpha, charge of alpha, and voltage. As already said, voltage is constant, Planck constant is constant, voltage is for proton and alpha will be the same. Now wavelength for the alpha is equal to h divided by root 2 times of 2 times of 2 into mass of alpha. It's 4 times of mass of proton. It's 4 times of mass of proton, and charge of alpha it is 2 times of charge of proton into voltage. This is a wavelength finally we will get for the alpha particle. Okay, so now we found what is alpha particle wavelength. Okay, then we are going to find what is wavelength of alpha particle is equal to h divided by root of it is 4 2 will get as 8. Okay, 8 into 2 times of mass of, because here 1 2 is the 2 times of mass of proton, charge of proton, voltage for proton. Okay, as I said, voltage will be the same. Now the same wavelength for the proton is equal to h divided by, so this equation will take it, it's a wavelength equation. It is root of 2 times of mass of proton, charge of proton, and voltage. Okay, it's very simple. Mass will be mass of proton, charge will be charge of proton. Okay, now we are going to take it this two ratio. Okay, so equation 1 and 2 division, 1 and 2 I'm going to divide. Okay, so wavelength of alpha divided by wavelength of proton. So when we are dividing both the equation, Planck constant get cancelled. Okay, mp get cancelled, mass of proton, charge of proton, voltage it's getting cancelled. Okay, 2 also will be getting cancelled. So we'll get it is 1 divided by root of 8 divided by 1. Okay, so we'll get as this denominator will its numerator denominator directly will come in a denominator. It's a 1 divided by root of 8. 1 divided by root of 8 we can take it as a it is 2 into 2 into 2, that means 2 times of root 2. So finally we'll get the ratio of alpha and proton wavelength is equal to, it is 1 is to 2 times of root 2. Okay, thank you for watching my channel. If you like my channel, please subscribe. Thank you everyone.